Permutations is used in our everyday life. For example, in the license plates of cars and vehicles, phone numbers, code of locks, and many more. By learning permutations, we will come to know the number of ways or arrangement of objects. We can arrange things creatively by predicting the number of possible ways to do it. So what is permutation? Permutation is an arrangement of objects in specific order. Take note, specific order. There are types of permutations. First, permutation of n objects taken all together, or also known as factorial notation. For example, suppose you wanted to know in how many ways can 5 decors be displayed or hung on a wall. We can choose any among those 5 decors to be hung first. The 4th decors will be hung next. The 3rd decor will be hung in the 3rd position, and so on. Decor A can be placed in any of the 5 positions, so there are 5 ways. Decor B can be placed in any of the remaining 4 positions, so there will be 4 ways. The decor C can be placed in any of the 3 remaining positions, so there will be 3 ways. Decor D can be placed in any of the 2 remaining positions, so there will be 2 ways. And finally, decor E will be placed in the remaining position. The solution can be written as 5 times 4 times 3 times 2 times 1 or equal to 120 ways. We will let n is equal to the choice for the first position. N minus 1 is the choice for the second position, while n minus 3 is the choice for the third position, and so on until n minus quantity of r minus 1 is the choice for the last position. Thus, to get the permutation of n different objects taken all together, they can be arranged in n times the quantity of n minus 1 times the quantity of n minus 2, and so on until the quantity of n minus the quantity of r minus 1. If n are distinct objects, the number of arrangements or permutations p can be written as n permutes n is equal to n factorial, or p n is equal to n factorial. There are some instances that not all objects in a group of distinct objects are chosen. So this is a type of permutation of n objects taken r at a time, or also known as n permutes r notation. The formula for that is n permutes r is equal to n factorial over the quantity of n minus r factorial. For example, in how many ways can 5 integers 1, 2, 3, 4, and 5 permute taken 2 at a time? The solution for that is we will use the formula for this type. We have npr, or n permutes r, is equal to n factorial over the quantity of n minus r factorial. Our n here is equal to 5. We have 5 distinct integers, 1, 2, 3, 4, 5, and our r is the 2 taken 2 at a time. So npr substitute equals 5 factorial over 5 minus 2 factorial is equal to 5 factorial is 5 times 4 times 3 times 2 times 1 over 5 minus 2 is equal to 3 factorial, so 3 times 2 times 1. We can cancel out 3 times 2 times 1 in the numerator, and also in the denominator 3 times 2 times 1, or equal to 5 times 4 is equal to 20 ways. The third type is the permutation of an indistinguishable object, or permutation with repetitions. Look at the word that. This word has a repeated letter, which is D. The 2 letters D are indistinguishable from one another since they are repeated. If the word God will be used, then interchanging letter D will not give a new arrangement, which will form a 3 new letter word. Similarly, if there will be 2 indistinguishable boxes, then moving all the content of one box to another does not result a new way of putting the objects. In this regard, there is need to know whether an object is distinguishable or indistinguishable. And the formula for that is n factorial over n minus 1, n sub 1 rather, factorial times n sub 2 factorial, and so on until n sub r factorial, where n is the total number of objects and n sub 1 is the indistinguishable object for type 1, n sub 2 is the indistinguishable object for type 2, and so on until n sub k is the indistinguishable object for type r. In general, repetitions are taken care by dividing the permutation by the factorial of the number of objects that are the same or identical. For example, how many permutations can be made from the word senselessness? So we have the unique letters S, E, N, and L. So our N here, the number of all letters, we have 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the number of S is 1, 2, 3, 4, 5, 6. We have 6S. And the number of E is equal to 1, 2, 3, 4. We have 4 letter E. And N, we have 2 letter N. And only 1 L. Using the formula given, we have n factorial over n minus 1 factorial times n minus 2 factorial n sub 1 factorial rather n sub 2 factorial times n sub 3 factorial. So we have 13 factorial over 6 factorial, 4 factorial, and 2 factorial. No need to put 1 factorial because 1 factorial will not give different answer. So we have, to calculate this one, the arrangement will be 180,180 arrangements. The last but not the least type of permutation is the circular permutation on n objects. Circular permutations are used when objects have to be arranged in a circular order, and the first object determines the beginning and the end of the arrangement. For example, in how many ways can 3 guests be seated around in a circular table? Consider a point of reference, let us say guest 3. So, we will put guest 1 here and guest 2 and interchange that guest. We have guest 3 remain as guest 3 here, and then guest 2, guest 1. Thus, in this case, there are 2 possible ways to sit the 3 guests in a circular table. Let's have example number 2. How many distinguishable ways can 4 people be seated around a circular table? The first arrangement is, let's say our reference is A. The first arrangement is B, C, D. Second arrangement, A, C, P, D. Third arrangement will be A, D, B, C. The fourth arrangement will be A, B, D, C. Fifth arrangement will be A, C, D, B. And the last arrangement will be A, D, C, B. Only the three letters will interchange because our reference point or our reference seat is letter A. So there are 6 ways to seat 4 people in a circular table. From the given 2 examples presented, it shows that the number of ways to arrange n objects along a fixed point of reference is equal to P sub n is equal to n minus 1 factorial. In n objects are arranged in a circle, the permutations of n objects is n factorial over n, or simply the formula n minus 1 factorial. That's all for today. Thank you and goodbye.